it.
702.
The Naked Scientist.
Time for The Naked Scientist with Dr. Chris Smit. We take all of your science-related questions on 011 883 0702 and the WhatsApp line 072 702 1702. Dr. Chris Smit, how are you doing?
Happy Monday. I'm doing good. Hello to you and all our listeners. How are you?
I am good, just recovering from that. After I spoke about that flu with you, then I went and got it.
Oh, no.
Yes.
Are you better now?
Getting there. We're almost there. We're almost there. I saw something, Doctor, and I thought I would ask you about it before we go to the lines, where it was speaking about the scenario of an Earth that could be donut shaped. And I don't know if you've heard about that conversation. So they're busy saying, based on the principles of physics, it is theoretically possible for a planet to have a donut-shaped structure. And they speak about maintaining the stability of the donut-shaped Earth. It would need to rotate at extremely high speeds. And they've even got a whole diagram of how the moon is circulating through this donut shape. Now, if we already know that the Earth is round, number one, why are we even exploring this? But number two, have you heard anything around this concept of a donut-shaped Earth?
Emphasis on around.
Yeah.
I haven't come across this, and it's an intriguing idea, but the reason we don't see routinely donut-shaped planets is because of the way that gravity works and the way that planets form. And while many things are theoretically possible and you could possibly create something that would look like that, it wouldn't form easily naturally. And the reason for this is that when a star first lights up, our star did that about 5 billion years ago, you have a big ball of gas and dust which under the influence of gravity falls in on itself and gets closer and closer, hotter and hotter, and eventually gets to the point where there's enough temperature and pressure at the centre of that star to start the fusion process. But around the margin or girth of that star is a pile of material which didn't quite make it into the star and slowly coalesces into a disk around the star, and that's called a protoplanetary or circumstellar disk. And under the influence of gravity, particles begin to congregate together. And once you've got some together, you've got more gravity than you had to start with. So they pull in even more and pull in even more. And you end up with these bodies forming. They're initially known as planetesimals, baby planets. And they go round in the orbit that they're on, slowly gathering and accreting more and more of the material through that disk. And the way in which you organize the material under the influence of gravity to make everything get as close and compact as it can be, because that's what gravity is trying to achieve. It's trying to pull everything as close together in as organized a fashion as possible, is to make a spherical shape. And this is why planets are spherical, whether they're made of rocks and hard stuff or gas giants like Jupiter, because this is the configuration where you have the greatest amount of close approximation of all the particles that you're trying to pull on each other. And they all pull effectively through the center of that mass, which is the core, the center of the planet. So everything is being pulled down towards the center. So although it sounds counterintuitive because half the planet is not in the center and half is in the other half, it will all act through the center of mass, which is the center, which is pulling everything down towards that point. So you will naturally, under the influence of gravity, form a ball. And this is why raindrops, although they're droplet shaped when they're coming down through the Earth's atmosphere, make a droplet of water on the International Space Station, and what do? You get a wobbly sphere. And that's the same reason the water particles are pulling towards each other, because they're all sticky and they're working a bit like gravity does, pulling themselves as close together as they can get in the most energy efficient way. And that's a ball.
All right. Thank you so much for that, Dr. Chris Smit. We've got a Polo in Orlando West. Hi.
Hi.
Yes, go ahead.
Hey, I wanted to ask that since carbon is the food of the soil in terms of agriculture that give us vegetables, since now that we're doing genetic foods and spraying the soil, how does the chemicals that they spray the soil destroy the carbon, and how it impacts on humankind?
Okay. Well, first of all, what's a plant? Plants are life forms just like we are, but they're special. Because apart from being some of the first life forms on Earth and some of the most important, and they are the most important, they're nature's solar panels. plants, trees have leaves, green leaves, because they're doing the process of photosynthesis. And in those leaves, which are giant solar panels, they are capturing energy and sunlight, and they're using it to drive a chemical reaction which gets carbon dioxide out of the air, and that's the carbon source, which is fixed in the leaf through this chemical process of photosynthesis to build the carbon atoms in carbon dioxide to make sugar, glucose. And that sugar is then redistributed through the plant and then used as the raw material to build stuff. You build the glucose up into polymers, big long chains of glucose, which has different chemical behaviors. Some forms of glucose are storage molecules called starch. You've probably eaten potato. Well, that's almost solid starch, which is lots of glucose molecules stuck together in a certain way, and it's a useful way of storing your energy. Other parts of plants are the fibrous woody bits, and those are celluloses, which are other polymers made by joining sugar molecules together. So the carbon doesn't come from the soil so much. The carbon comes from the air. That's the main source of carbon in the form of carbon dioxide. Some nutrients, of course, do come in through the roots, micronutrients, other important vitamins for the plant, phosphorus being one of the most important ones, and nitrogen as well. They're absolutely critical for making DNA, and plants can't make new cells if they can't make more DNA, so they rely on that coming in from the soil, and they're aided and abetted in gathering that from the soil by fungi, which team up with the plant roots, and the fungi help to bring those chemicals to the plant. And then there's a subsoil bartering economy going on where the plant gives what it's got, some sugars and energy and things, and the fungi surrender to the plant in return some of what it's got, which are some of these micronutrients that the plant needs. And this economy helps to keep the plant fed, and that in turn then leads to a bigger, healthier plant. So the soil does have carbon in it. It has carbon in it because it's got living things in it, but it's not the chief source of carbon that goes into the plant. The air is the chief source of carbon that goes into the plant to enable it to grow.
All right. Thank you so much, Apollo, for that question. Let's go to Thibo, the foodie in Johannesburg South. Hi.
Hi. Thank you, Relebogile. Thank you, Nikki. Thank you so much too. Now, as you understand, what we know about the solar system is that space-time is bent. The sun, the gravitational force of the sun, or the radiomagnetic force of the sun, has bent space-time. This is how everything in the solar system is now revolving around the sun. And that happened because of the Big Bang, when everything went out in outer space. But now, shouldn't it be that everything that is revolving around the sun has now, well, the power that of the Big Bang has now dissipated. So what is now, because the space-time is bent, so what is keeping those objects that are revolving around the sun along their own axis around the sun, what is pushing them to go forward? Like, we know that they are on their own axis around the sun because the sun is bent space-time. But what keeps pushing them? What keeps pushing the object in our solar system to go revolving around the sun?
Thank you so much.
So your point is a good one, which is that the Big Bang created the universe and there was a lot of energy. So things which came out of the Big Bang had a lot of energy, and some of that energy has been converted into mass and material and chemicals and particles, which are forming the stars, which in turn are born, they die, explode, and produce more complicated elements that then recoalesce elsewhere in the universe. The reason, though, that we're all in motion and moving is because things, when the universe formed, had intrinsic motion. They had kinetic energy. They were already moving. And there's no way when you have something, if you think about Isaac Newton, his famous rules and laws, that something remains at a constant velocity unless a force acts on it to change its velocity or its direction. So we're moving through space. We're not moving through space so much as because of the Big Bang. We're moving through space because the particles that formed our planet and our sun and the other planets in the solar system, those particles had momentum already. And that's partly because of the Big Bang, but it's because everything in the universe is moving. And so the net direction of movement is when you add all the different relative velocities, directions and speeds of those particles together, you end up with a direction of travel. And all of the material, the gas and the dust that formed the sun and then ultimately would have formed the planets was all moving and swirling round. And when you add together all the particles, the net direction of travel is adding together, is arrived at by adding together the momentum of all of the individual particles that are in there. And it just so happens that we're going round in a certain direction because that was the net product, sum of all the momentum of all the materials. And there is nothing exerting a force on us to stop the movement. The sun is exerting a gravitational force inwards towards the sun, and that holds us on our orbit. We are exerting a gravitational force on the moon, and that holds it in orbit around the Earth. And over the early years of the solar system, all the different planets jockeyed for position, exerting gravitational forces on each other, and there were various resonances because of that. But we're now in a stable configuration where everything's roughly tugging on everything else in a balanced way. So it's in a status quo, and with nothing pushing on the Earth to slow it, then it continues pretty much at the same rate ever since.
Thank you so much, Thibo, for that question. We've got a question from TK in Pretoria. Hi, TK.
Hi, Relebogile and Dr. Chris. I'd like to ask, what is it with insulin that in some people it might cause obesity when there's too much sugar intake, and then on some people it doesn't cause obesity? What controls that?
This is a $1 billion question because
it's called luck. Some people got luck.
half the world population is now overweight, and we do have a malnutrition crisis. It's not a lack of calories, it's a lack of wholesome, healthy calories, and this is turning the world into an unhealthy, overfed state. Everyone's carrying too much weight. We don't know why it is that some people can exist in this environment that we've created and not gain weight. And as it was put to me by quite a famous metabolic scientist, Steve O'Reilly at the University of Cambridge, we made a radio show about 20 years ago looking at the question of why is it that there's this profound increase in the rates of obesity and overweight in the world population in the last about 3 or 4 decades. Prior to that, very, very few people were overweight. Now, very, very many people are overweight, and it's almost certainly the worst pandemic in terms of health threat that we've confronted in the history of mankind, in terms of the effect it will unleash on society because of ill health and being a huge risk factor for diabetes. And the fact is, we haven't changed genetically in 5 years, 5 decades. Nothing evolves that quickly in human terms. So it's not that we've genetically changed. So something else must account for the fact that we've gone from very few people being obese to half the world population being overweight. A third of some countries are obese. And the answer to this question is almost certainly the environment has changed. The environment we're living in, the lifestyle we're living, the food we're eating has changed. But as Steve O'Reilly put it to me, the question isn't why is everyone putting on weight? The question is why are there some people in the population who, despite those threats, don't put on weight, and they're the ones we should be studying. And there's a range of different reasons why this happens. Some are that some people are extremely good at just eating the right things and not eating the wrong things, so they have more willpower. Some people are much more fit and active, and because activity can burn off maybe a third to a half of the calories you get through in a day, if you're highly active and you're also living in colder conditions, because turning food into heat is one of the things our body also does to keep us warm. So you boost your metabolic rate, that burns off calories. There are some people who do this very well. There are other people who do this much less well. And it may be, therefore, in the population, there are some people who just are very good at handling a high calorie load and not gaining weight. There are other people that don't handle those calories because they just don't eat them in the first place. There are some people who don't absorb the calories properly because they have other health problems. But then there are the people like the normal person who probably because of the genes they inherited from the evolution of humankind going back millions of years, those individuals are victims of the environment we've created, which is an obesogenic one. It makes us gain weight. And that's the question then. Why is that? What is it about the foods that we're eating? What is it about their subversion of how we like to eat things at what sorts of rates and in what sorts of quantities? And is our working day making this more likely? Those are the sorts of questions that people are now delving into to try to get to the bottom of what is, as I say, behind arguably the worst pandemic that the human race has ever faced.
Thank you so much for that question. TK, we've got Lufuno on Joburg Central. Hi, Lufuno.
Hi, good afternoon, Relebogile and Dr. Chris. As I'm growing old, now, as a young person, I didn't have much hair. I'm a person
Lufuno, you're speaking like you're 89 years old. How old are you?
I'm now I'm
28.
turning 59 tomorrow.
You're turning 15. Okay, so you're nice and young, and a very early happy birthday for you for tomorrow. So as you're getting older, you're finding that?
I'm finding that there's hair that grows so much in my nostrils and my ears and my eyebrows, whereas my hair on my head is falling off. I don't know. So what's this thing? And the hair in my nose irritates me.
Lufuno, you know that your ears and your nose are solving the issue of your head. The problem is you're not telling your hairstylist to shave there and stick on the top. But that's a very, very good question. Doctor, are you finding that it is a normal occurrence where hair loss happens up there, but the other areas, hair growth increases?
As we go through life, hair follicles in different parts of the body can be recruited and mature and become more active. And often this happens under the influence of the male hormone testosterone. And so as we get older, because those parts of our body have seen more testosterone over a lifetime, in those areas, you tend to get bushier, more florid hair growth. This doesn't happen so much in women, at least until the age of the menopause, because A, the testosterone level is lower, and B, other female hormones suppress the sensitivity of the body to testosterone. But after the menopause, when the levels of estrogen and these other hormones are lower, then you may see more of these effects, which is why some women do say they get hair changes after about the age of 50. But what's going on with your head then? If you've got this hormone, testosterone, that makes you hairier everywhere else, what's going on with the head? Well, the answer is that there is a gene which is carried by the X chromosome, which makes a condition called male pattern baldness. We don't know exactly why this happens, but people who carry that gene, and because men only have one X chromosome, if they happen to have that gene on their X chromosome, then they are susceptible to male pattern baldness. And this is where testosterone, for reasons we don't understand, poisons the hair follicles on the top of your head in a certain distribution. And there are certain places which are more vulnerable than others. And that's why you tend to get initially thinning at the temples, and then a retreat of the hairline, baldness on top, and then eventually it goes around the sides and around the back last. And we don't know why this happens. We don't know why the hair follicles there are susceptible to these testosterone derivatives, but that is why you lose hair from your head. But the same hormone is busy recruiting hair follicles elsewhere on your body and making them become much more active, because those are not genetically programmed to be poisoned by testosterone elsewhere on your body.
Thank you so much, Lufuno. And I'm sure many men are sitting in their cars, doctor, and thinking, I've been wanting to know the same thing. Let's quickly go to Mapuke in Tshwane. Mapuke, go ahead.
Hello, Relebogile. Yes, I used to believe in scientists until I read that they faked the moon landing.
How? Who said they faked the moon landing?
No. Let me explain. Until I realized that they've faked the moon landing. Now, the scientists is saying to us that the Big Bang is responsible for the creation of the universe. No one was present at the time. They were saying theory and conspiracy theory to tell us about how the universe began. But none of them know how it happened. So now I'm asking a question to him. Has he ever felt the earth move? Because they say the earth is spinning at 1,000 miles per hour. Has he ever experienced the earth move? Thank you very much.
Wait, before you go, Mapuke, are you saying that you've believed all of this science until you read something somewhere from a source that you might not remember right now that says that the moon landing was faked?
The moon landing is fake. Antarctica is fake. Everything is fake. Everything is it's a fake and a lie.
Okay, so let me do this for you, Mapuke. I'm going to ask you to listen next week because we're not going to have time to go into the full details. But let me say this. Dr. Chris Smit, I learned a few years ago about this concept called confirmation bias. If there's something you want to believe in, you can Google it and you'll find information to support what you believe. So if you believe that the moon landing was fake, please know the information will be there. If you want to believe that the billionaires that went down in the submarine didn't actually go down, you will find that information there. So I'm leaving it on that note because I know, Doctor, you're going to have a lot of information you're going to need to answer to that one. And we have covered this before, but we'll pick it up next week. Is that a fair way to end it, Doctor?
It is, and you can find in that same book about the faking of the moon landings, the fact that the Earth is flat. And
then you go to the Facebook group of the Flat Earth Society, and they say we have members all around the globe.
I know, it's funny, isn't it? They haven't quite seen the irony in that one.
Thank you so much, Dr. Chris Smit. We'll be back together next week. If you want to send through any of your questions during the week for Dr. Chris Smit, send us an email, 702afternoons@702.co.za. That's 702afternoons@702.co.za. Any of topic suggestions, people you want us to interview, we are 702 family, and of course this show is all about you.